Okay, so I want to talk about improper integrals in this video. And so what I want to do is I want to figure out what is the area between the x-axis and 1 over x on the interval I want to figure out what that red area is. Now I've got a problem because technically speaking I can't put 0 into here. So 0 doesn't work in this function. It's not defined. 1 over 0 is not defined. So I got a problem right there, and so I've got an improper integral. And so I go to Wolfram Alpha widgets gallery, blah blah blah. I sort of talked about this before. So this is the Wolfram alpha.com definite integral calculator, and I ask it to go from 1 over x from x equals 0 to 1, and it writes it out, and it says the result: the integral does not converge. Non-integrals, it's a singularity of the integrand in the integration interval. So in other words, I can't do it. This area here is infinite. But if I tweak it a little bit, I can make that area smaller. So I can do that to the 0.5, and I can do this. I copy that, paste it, make this all blue, make that to the 0.5, and now I was saying that that red area is infinitely large. But what about this blue area? This blue area is smaller than the red area. And so the blue goes towards the y-axis faster than the red does. So this is still improper because if I plug in 0 for x, I get 1 over the square root of 0, which is undefined. But if I go over to Wolfram and I change that to the 0.5 and I submit it, it computes and it says that the answer is 2. So some integrals are more improper than other integrals. The area in red is infinitely large. The area in blue is 2. So there's a very, very fine line between 2 and infinity when you really sort of think about it. Okay, so then if I go back and start playing around with this, well, how about x equals, how about x to the 0.9? Well, x to the 0.9 is 100. How about x to the 1 over x to the 0.99? Well, it's going to be, well, that was 10. The previous one was 10. 1 over x to the 0.99 is 100. And if I keep going out, it doesn't like that input. But basically, the point that I want to make is that I can solve this just as long as it's not 1 over x to the 1. Anything less than 1 over x to the 1 is going to have a solution. So if I go if I do, well, this online, when we get into improper integrals, things get a little bit confusing, and the computer gets messed up because the computer doesn't like improper integrals. But the point that I want to make is that as long as this exponent is less than 1, I will come up with an actual solution on the interval from 0 to 1. But then, so then let's look at it the other way. Let's look at y equals, let's just hack this one. Now let's look at this one, but let's go from 1 to 10 to the 30th. So now let's not. So now I want to figure out what this area is. So this area gets smaller and smaller and smaller and smaller and smaller and smaller and smaller. And now the problem is when we run into the computers is that the computer doesn't really know how to do infinity. So the computer doesn't like infinity. So I'd say 10 to the 30th and see what it has to say. And it says it doesn't converge. So it's going to, well, here I went from 0. Let's go to 1. Okay, so it gives me the log of 10 to the 30th. So it's going to equal the log of 10 to the 30th. Well, as long as I put larger numbers in for this, as long as I put larger numbers in, I'm going to get a larger number out. So the problem with this graph is, once again, this one, 1 over x integrated from 1 to infinity, is going to give me an infinite solution. But let's change it to 1 over x squared. So now, once again, I want to go from 1 to 10 to the 30th. Now, once again, my blue is smaller than my red. So let's just see what happens if I go over here, make this x squared. It's going to say approximate, it's going to be a whole bunch of 9s over one more. So it's a big number. Well, this is going to be basically n. So it's going to be n minus 1 over n is what you're going to get. N minus 1 over n, and that's going to be approximately equal to 1. So to say what I was talking about improper integrals again, 1 over x, the integral of that from 1 to infinity, that red area is infinitely large. 1 over x squared, that red area, that blue area is equal to 1. So again, it does not look like there's a big difference between the red and the blue, but there's all the difference in the world between infinity and 1. Red has an area of infinity, blue has an area of 1. So it all has to do with, so once again, we cannot integrate from 1 to infinity, but if we could, the red would blow up, the blue would stay finite. And once again, if I did 1.01, they almost look the same. Let's see what this has to do, what this has to say. It's thinking. Basically, 49.8813. Maybe it's 49. I'm not sure. Let's see if it does likes that or if it doesn't like that. Okay, that seems to be blowing up in terms of what they're talking about. But I might have just hit the limits of what I could do. Basically, I'm going to say if you work it out on paper, you're going to get, you should get 50. I think you should get 50. But I'll let you work that out on your own. So, even though we can't even really tell the difference between the blue and the red on this graph, there's just this tiniest little sliver between the blue and the red. Nonetheless, I'm going to argue that oh, that's not what I wanted. Nonetheless, I'm going to argue that the blue has an area of 50 and the red has an area that's infinite. And so that's my little lecture on improper integrals, and you can sort of think about that one for what it's worth.